Okay, we're going to take a look at question 3D, although it's not an excellence question. I think that the way that the schedule did it was a lot harder than it needed to be. So I'm just going to sort of give you an alternative kind of explanation for how to do this question, and hopefully it might clear up some things. So in order to do this question, it says, show with the use of calculus that the line y is equal to 11x minus 14 is a tangent to the graph of the function. So since I've got both the functions, the linear, the line, and the parabola, I just drew it so I could sort of see for myself what I'm talking about. Basically, we have to find a couple of things. In order to understand, in order to basically prove that a line is a tangent to a curve, there's two things that you have to find. You have to find the point of intersection, and you have to figure out that what that point of intersection is. And in order for a line to be a tangent to a curve, it intersects by definition at one point only. It can't intersect at 2 points. Okay, so the other thing that is incredibly important when we take this another step further, so we know that it's a tangent if it intersects at 1 point, but also with regards to calculus, the other point that's incredibly important to understand is that the gradient or slope of that line has to be equal to the derivative at that particular point, right? It has to be equal to the gradient function, because basically at this point the tangent is telling me what the gradient is, the rate of change at that particular point. So it has to be, the gradient of that tangent has to be equivalent to the derivative at that point as well. So we need to prove both these 2 points. So to do that, first of all, we could solve by finding the point of intersection. So we'll solve these, make one equal to the other, and then elimination or substitution, whatever method you want to use to solve. We end up getting 2x squared minus 8x plus 8 is equal to 0, and we solve for x, and we get x is plus 2. Just one real root. So x is 2. We've got 1 point. So we know, and then we can stick the 2 back into one of these equations. You know, it doesn't matter which one, and we get the coordinates. So 2 and 8. So this point here is 2 and 8. And by solving it, we realize that the tangent, in fact, only hits the curve at 1 point. So we've ticked that off. Tick, 1 point. Okay. Now the other point is we have to prove that the slope of that particular line, the gradient, is equal to the derivative. This is where the calculus comes in. So we can't stop here. So is the slope of the line equal to the derivative of that point? So what we have to do, obviously, is we have to do the derivative. And when you see anything with tangents, you should know automatically that you're going to have to do derivative work. So we do the derivative of the 2x squared plus 3x minus 6, and we get 4x plus 3 when we do the derivative of the quadratic. Now, we know that we have a point of intersection, 2 and 8. So is this line, is it got the same gradient as basically the derivative? So how do we find that out? Well, we differentiate it. We got 4x plus 3. If we stick x is 2 into that derivative, so at that point of x is 2, if the derivative is equal to the gradient of that line, then yes, the line is a tangent. So we test it. X goes in, x is 2, and it ends up giving me 11. 11 is in fact the gradient of that line. So we've now proved the slope is equal to the derivative at that particular point, and we're done.